In this video, we need to prove that the sum of the squares of the diagonals of a parallelogram is equal to the sum of the squares of its sides. Diagonals of a parallelogram bisect each other, therefore O is the midpoint of AC and BD. AO is equal to CO and equal to half of AC. BO is equal to DO and equal to half of BD. Let's review the triangle ABD. By the Apollonius theorem, the sum of AB squared and AD squared is equal to 2 times AO squared plus 2 times BO squared. If you are not familiar with this theorem, please check the link to a video with the proof of this theorem in the description below. Let's review the triangle BCD. By the Apollonius theorem, the sum of BC squared and CD squared is equal to 2 times CO squared plus 2 times BO squared. Let's add these two expressions together. AO is equal to CO, 4 is equal to 2 squared, 2AO is equal to AC, and 2BO is equal to BD. And we just proved that the sum of the squares of the diagonals of a parallelogram is equal to the sum of the squares of its sides. Thank you for watching. If you found this video helpful, please consider to subscribe to help my channel grow. Thank you.